Okay, I'm going to go over a few things about the mean, median, and the mode, what we call measures of central tendency. Each one of them has its pros and cons. The mean is all other things equal the best, followed by the median, followed by the mode. Oops. Now, when we talk about central tendency, the question is, well, how do you define it? It's really just trying to get a single number to represent a distribution or its most quote-unquote representative score. And we have the mean, the median, and the mode to try to do that. And the idea is, again, statistics, descriptive statistics anyway, are meant to simplify, organize, summarize a bunch of data because you don't have time to interview 10,000 workers, but you do have time to look at individual averages if you're trying to make some kind of decision. So they come in really, really handy. The thing is, though, that you're trying to represent what is the typical person like, what is the average person like, which is why we use the mean or the average. Now, the mean is the same thing as an average. You add up all the scores and divide by the number of scores that we have. In populations, mean is represented with a Greek letter, and anytime we talk about populations going forward, we will be using Greek letters. And it's really just the sum of x, again, that means add up all my x values, or all the scores, divided by n, and that gives us our population mean, or mu. For a sample, we use, in this class, we use uppercase capital M, and it's really just sum of x divided by little n, signifying that we have a sample. You know, no real rocket science here for a population of scores. I add up all my scores, divide by the number of scores, I get my mean. For a sample of 6 scores, I add up all these scores, divide by 6, get my other mean. Now, when we're looking at the mean, we can also calculate the mean for 2 or more groups, and in this case we're going to call a weighted mean. So if I have 2 samples, like in this case group 1 or sample 1 has 4 scores, group 2 or sample 2 has 6 scores, I can put them up here like this, and I can get my sum of x1 and x2, or my sum of group 1 and group 2, 28 and 36. And I can look at how many people I have, right, in each case. Then if I want to, I can add all those things together, divide by the total number of people I have, and it gives me a value of 6.4. If I wanted to calculate the average for each individual group, I could call it average group 1 and average group 2 by themselves. And in Excel, I can just specify that I want the average, and we'll go over how we do these things. Highlight the right thing, and I see that I have an average of 7 in that case, and in the second case I have an average of 6. Now, if I were using an unweighted mean, meaning I wouldn't care that one group had more people than the other, my average of the 2 groups would just be halfway between group 1 and group 2 means. So it would be 6.5. However, because I have more people in group 2, the overall average, when I'm looking at weighted means, will always be a little bit closer to the mean of the bigger group than it is to the mean of the larger group, or of the smaller group, sorry. So in this case, because I have more people in group 2, my overall average has to be closer to the average of group 2 than it is to the average of group 1. And the bigger the difference in the size of each sample for each group, the farther it's going to be towards that actual mean. So in other words, if I just had 7 here, if I change that, notice that my n went down, my average stayed the same. Down here, my sums are changed. But now my overall average is 6.14285714, much closer to 6 than the 6.4 that I had before. And we'll go over a few samples of this in class, but just briefly. Now, some things that we have to think about because we usually are looking at means, we have to think about how different scores change that mean. And this is really important when you're dealing with small samples. Not that big of a deal when you have thousands of people. But if I have these scores here, 3, 2, 0, 1, 5, 1, my mean is 2. And I'm going to just change this right here and make it 3, 2, 0, 1, 5, 1. And then my average down here, I'm just going to hold this. I'm going to hide this other stuff here. So my average here is 2. If I change the 3 to a 9, you can think that, well, my average is going to increase, right? Well, absolutely, it goes up to 3. If I change the 5 to a 2, my average is going to go down. Now, the rule of thumb is, if I'm going to change any score, if I make it bigger, my mean gets bigger. If I make it smaller, my mean gets smaller. Another question we might have is, what happens if we add or remove different scores? Suppose that I add a 9 to this group of scores. Oops, well, I gotta change this. Put a few more. Now my average goes up to 3, right? If I remove that 9, it goes back down to 2. If I remove the 5, well, because this 5 is bigger than my mean is going to have to go down. When I add scores, if my score is bigger than the mean increases. If it's smaller than the mean decreases. If it is right at the mean, well, then the mean is unchanged. Now, if I work with constants and I'm adding or subtracting scores from each thing, suppose that I add 2 to each of my original scores. So 3 plus 2 is 5, 2 plus 2 is 4, 0 plus 2 is 2, 1 plus 2 is 3, 5 plus 2 is 7, 1 plus 2 is 3. And so if I add a constant, well, the same thing happens to my mean. If I subtract 1 from each score, well, the same thing again happens to my average. If I multiply or divide, the same thing's going to happen to my mean. Now, this may seem pretty trivial, but it's important to note that anything with the mean, anything I do in terms of constants, adding, multiplying, dividing, subtracting, the same thing is going to happen to my mean. When we deal with standard deviations in class next week, or this upcoming week, we'll find that adding and subtracting doesn't change the standard deviation at all, but multiplying and dividing does. We'll say too that the mean is the best measure of central tendency, but you need an interval and or ratio scale of measurement to use it. If you have ordinal data, you have to use a median. If you have categorical data, you have to use the mode. So the benefits of it is that it's generally understood by most people and gives you the most accurate picture of things. It's most useful. The limitations are you are confined to interval and ratio scales. The other thing is that outliers also have a gigantic impact. And when I say I have an outlier, well, what that is really trying to say, what I'm trying to indicate there, is that I have one score that doesn't seem to fit. So if I look at this example, right, if I have group 1, and let's say I have 2, 1, 2, 1, 2, 1, 3, we'll change that to 1. Average of 1.5. An outlier in this case would be something as simple as 7, right? Everyone's 1 or 2, except this 7 exists. I could make it more extreme and make it 21. Maybe somebody was trying to enter in their data, instead of putting a 2 followed by a 1, they put in 21. Well, now what I have as an average is a 4.2, and it doesn't really represent anybody in the sample. And if the sample is a good representation of the population, it doesn't represent anybody in the population either. And the goal of the mean is to try to represent everybody as simply and as accurately as you can. So use when you have an interval or ratio scale and you have no extreme values. The second one is the median. And the median is just the middle score. So if I take all my scores and divide them in half after I put them in the right order, then the median is just that middle number. So if I have these scores, first step is I put them in order from lowest to highest. 1, 2, 3, 4, 5, 6, 7, 8. And I look at, well, what is my middle score? Well, the middle score is 4. That's the median. If I have an even number of scores and I have the same amount of scores on one side of the really midpoint as I have on the other, then I just take the two middle scores and average them. Note that in some cases I might have two middle scores that are the same, in which case it really just stays as those two middle scores. Now, the good thing about the median is that it's not impacted by extreme values. So if I'm going to look at the median of these scores, right, it's 1.5, just like my lovely average. However, suppose I change this to 100. Well, my average goes up a ton. My median hardly changes at all. And if I were to have actually, another 1 in here, my median wouldn't have changed at all, because my middle score would have still stayed the middle score. Likewise, if I would have changed the 2 to 100, now my average changes, but again my median doesn't change at all, because my middle score still, and because I have an even, my middle two scores are a 2 and a 1, it takes the average of those two scores. The problem with the limitations, or the problem with the median, are that you might not really again be representing anyone at all. If I have a bimodal distribution where I have, say, 6, 7, 8, and then 1, 2, 3, well, my average and my median are both 4.5, and again, same problem comes up that a 4.5 doesn't really represent anybody in here, especially if I had something as simple as a totally bimodal distribution where I have just really two values, right? You're either a 7 or a 2, and when I try to represent the typical person in this group, I'm not really representing anybody at all. Use this, though, when you do have extreme values, when you do have outliers, when you have very highly skewed data, so positively skewed or negatively skewed, either one really high or several really high scores or several really low scores. The variable is open-ended on one side, which will give you skewed data, or if your data is ordinal. And you can use the median with ratio, interval, or ordinal data, which is nice. It gives you that extra option. Now, when we go into class, I'll go through a little example. Can't show it on my computer because the security software on the school's computer does not let me use this particular website. Finally, we come to the mode. And the mode is the score category that occurs the most frequently. Not a whole lot to this. You look at how many numbers you have of each, right? So I have 1, 1, 1, 2, 1, 3, 4 4s, 1, 6, 1, 7, 1, 8. And so 4 happens the most, so that is my mode. If I look at this one, 2 is my mode because there are the greatest number of 2's in this case. You can have more than one mode. In some cases, I may have two numbers that are most frequent. Then I would have a bimodal distribution. If I have more than two modes, I'd have a multimodal, and we'll go over this briefly in class as well. Benefits. It's not impacted by extreme values at all. Any outliers have really no effect because usually, outliers are always unusual scores, and so there aren't a lot of them. And so you don't really get any impact on the mode at all. The mode is the only way to represent categorical data. So if it's categorical, nominal, you have to use the mode. And you can always throw it in to enhance the meaning of the mean or the median. Problem is, of course, it's not always by itself representative. In this case right here, group 1, I have basically two modes that tell me everything about everyone. Or I could have something right where I have 2, 4, 6, 8, 10, and then another 2. Well, that doesn't really represent the data by itself. You need to have some kind of distribution with a pretty nice bell curve or at least some kind of peak to have it be meaningful. So use it when you have categorical data or when the mean and the median don't tell the whole story. Final thing is, when you think of a distribution and whether it's positively skewed or negatively skewed, when I have a symmetrical distribution, my mean, median, and mode are exactly the same when it just has one peak. If I have a positively skewed distribution, the mean is always affected the most by these outliers, so it gets pulled up the most. The median gets impacted just a little bit, and the mode doesn't really get impacted at all. So my mean will be the highest, my mode will be the lowest, and the median is always in between the other two. In a negatively skewed distribution, I have the opposite thing occurring. The extreme low scores are pulling my mean down, my mode isn't really affected, and my median is affected just a little bit. So my lowest score in a negatively skewed distribution is the mean, median's in the middle, and mode is the highest. Now when we have class, I expect you to be able to do these calculations. They're not that difficult really. And we'll start off with a short review, and then we're going to work with measures of variability. Because when we look at different types of data, we don't just care about what that typical person is like. We want to know the range of possibilities. What's the best case scenario? What's the worst case scenario? We'll start really with this little exercise. It'll require you to deconstruct this table, make sure you know that this is 1 5, 2 4s, 3 3s, and so on. And we'll take it from there. So see you on Wednesday.